Hello, how to solve this exponential problem? This is n power 3 over 2 equals 2 power 3 over 2. We are solving for all values of n that satisfies this equation. Now, the first step is let's factor out this 1 over 2 from here. Remember, if I have a power n over m, this is just like writing a power n times 1 over n. So I can apply this right here and here. So we have n power 3 times 1 over 2, and this equals 2 power 3 times 1 over 2. So remember, if you have a power n times m, this equals a power n raised to the power of n, and also equals a power n raised to the power of n. So I apply this right here and here. So I'm going to have n power 1 over 2 raised to the power of 3 equals 2 power 1 over 2 raised to the power of 3. So right now, if I have a power 1 over 2, this equals square root of a. So I apply that here and here. So I'm going to have square root of n raised to the power of 3 equals square root of 2 raised to the power of 3. I move this over here. So I'm going to have square root of n raised to the power of 3 minus, this comes over here, square root of 2 raised to the power of 3, and this equals 0. So at this particular point, I have power 3 here, I have power 3 here. See, if I have a power 3 minus b power 3, this equals a minus b times a squared plus a times b plus b power 2. And in this case, my a equals square root of n, which is this, and b equals square root of 2, which is this. So I'm going to apply this identity. That means I'm going to have a minus b will be square root of n minus square root of 2 times square root of n raised to the power of 2 plus ab square root of n times square root of 2 plus b squared square root of 2 to the power of 2, and this equals 0. So what I'm going to do will be this cancel this cancel this. I will simply have square root of n minus square root of 2 times this is n plus this times this square root of 2n plus 2 equals 0. So at this point, I'm going to equate each of these to 0 as square root of n minus square root of 2 equals 0. Half n plus square root of 2n plus 2 equals 0. So let's solve these individual equations. I'm going to start with this one here. If you have square root of n minus square root of 2 equals 0, and move this over here, and square root of n equals square root of 2. So what happened here is that this cancelled this, of n equals 2. So this is my n1. So I need to also solve this other equation to find the other values of n. I'll move 2 over here. I'll move n over here. So I'm going to be left with square root of 2n equals negative 2 minus n. The square root here, I need to eliminate the square root by taking the squares of both part of this equation. This cancel this. Of 2n equals, this is power 2. I have minus 2 minus n times negative 2 minus n. So right now, I'm going to have 2n equals negative 2 times negative 2. This is 4, negative 2 times negative n, plus 2n negative n times negative 2, plus 2n this times this, plus n power 2. So from here, I have 2n equals 4 plus 2n plus 2n. This is 4n plus n power 2. So right now, what I'm going to do will be to move this over here. This becomes 0 equals 4 plus 4n plus n squared minus 2n. 4n minus 2n, that is 2n. I have 0 equals 4 plus 2n plus n power 2. So let's rearrange this equation. I'm going to have 0 equals n squared plus 2n plus 4. Meaning we can rearrange this, we can have n squared plus 2n plus 4 equals 0. I have this quadratic equation that I'm going to solve for the other values of n. So we are going to solve this quadratic equation using the formula method. So let's write the formula in respect to n. We have n equals negative a plus or minus square root of b squared minus 4ac divided by 2 times a. 1 is the equation of n squared, that is my a. This is my b. This is my c. So from here, I have n equals negative 2 plus or minus square root of b squared 2 power 2 minus 4 times 1 times c divided by 2 times a, that is 2 times 1. From here, I have n equals negative 2 plus or minus square root of this squared is 4 minus this is 16 divided by 2. That is 2 times 1, that is 2. From here, I have n equals negative 2 plus or minus square root of 4 minus 16. This is negative 12 divided by 2. So from here, there's minus here. I can have n equals negative 2 plus or minus. There's minus here. I have square root of negative 1 times square root of 12 divided by 2. So from here, I have n equals negative 2 plus or minus square root of negative 1 is I. I have I times this is square root of 12. I can express it as square root of 4 times 3 divided by 2. So from here, I can have n equals negative 2 plus or minus I times square root of 4, 2 times root of 3 divided by 2, 2 cancels 2 cancels 2. I have n equals negative 1 plus or minus I root 3. So I have two values for n, the complex solutions. I have n2 will be negative 1 plus I root 3, and n3 will be negative 1 minus I root 3. Then I also have one real solution, which is my m1, and that is 2. So what I'm going to do will be to check by inserting the 2 right here. I've checked n equals 2. I insert 2 right here. I have 2 power 3 over 2 equals 2 power 3 over 2. Now remember, if I have a power n over m equals the m root of a power n. So that means if I apply it here and here, I'm going to have the square root of 2 power 3, which equals the square root of 2 power 3. And 2 power 3 is 8. I have square root of 8, which equals square root of 8. Left hand side equals right hand side. So that is it, guys. Now guys, this is it, and don't forget to subscribe and share. Now a quick recap is the first step is to factor out 3. Then you have this, then once you have this here, you apply this identity. A power n times m equals a power m or power n. You apply it here and here. You take the square root of both parts, then you have your power 3 right here. Power 3 right here. So at this point, you move it over here, you expand it using this cubic identity. A power 3 minus b power 3 equals this. Then at this point, a minus b, your a is root n, your b is root 2. You insert it right here. Then this will give you two different equations. This is equated to 0, and this is also equated to 0. So you solve the first linear equation, which is this. By moving this negative root 2 over here, it becomes positive root 2. You cancel out square root, cancel square root. You have n equals 2. For this, remember the square root of 2n here. For you to solve it, you move 2 over here and n over here, so that you can eliminate the square root by taking the squares of both part of this equation. So you expand it, making write it in two places and multiply out negative 2 times negative 2, negative 2 times negative n, this times this, and negative n times negative n. Multiply out, then collect like terms. You are going to be left with this quadratic equation, which you are going to solve using the formula method. Then you are going to have two complex solutions when you solve that using the formula method. And the two complex solutions are negative 1 plus I root 3 and negative 1 minus I root 3. So ladies and gentlemen, this is it, and this is how you can actually solve this type of an exponential problem step by step. So that is it. Don't forget to subscribe and share. Thank you. See you again.